Okay, let me show you something. I've got this set back to voltage, power on. Now, do you hear that kind of hard rat-tat-tat? It's there's a very distinctive, louder, sharper. And you see how the voltage goes clear to the top. This meter is set not to react super fast, so it's actually taking its time to come back down to zero. But check this out. See how it goes clear as it goes right off scale. Well, what's going on? If you look down through the particle board here, you can actually see a bright light. This is the spark tester protecting its own circuitry. There is not a fault in the wire that you can drive a spark through with less than about 1,000 volts. And if you try going higher than that, then the spark tester is going to start arcing itself in its own circuitry. So there's a little spark gap built in under there, and if the voltage goes high enough and it doesn't find a spark in the wire, a place to spark in the wire, then it actually sparks in a controlled set of contacts in the spark tester. You can hear it. With this version you can even see it when you look in there at just the right spot. And you can tell because the voltage goes clear to the top and there's a very distinctive sound to that spark gap discharging inside the tester itself. And this test, I didn't have the leads hooked up to anything. They are half a foot apart, so that's what I got there. Now, one of these wires, well, anyway, so if you get that, if you get the needle pegging itself, a distinctive arcing noise instead of more of a pleasant buzzing noise, and if you look just right through the particle board, or through the peg board, you can actually see the arc happening. It's under there somewhere. There it is. Then that's telling you you're wasting your time. There is not a gap you can drive a spark across. So figure out another technique.